Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on August 29, 2025, just 4 days ago. The standout is a simple, training-free re-ranking method that picks better reasoning chains by maximizing a joint confidence score, delivering gains like plus 10.18 on MATH500 and plus 9.81 on AIME2025 over self-consistency while using far fewer samples. The paper is titled PiCSAR, Probabilistic Confidence Selection and Ranking, and as we will see later, the results are really impressive. In short, the method combines reasoning confidence and answer confidence, works across models, and often wins with only 6 samples. On X, a researcher frames PiCSAR as a simple, training-free selector using probabilistic confidence, highlights gains on AIME2025, and notes broad generalization, attracting modest engagement with 73 likes. Alright, the previous segment sketched the core idea. Figure 1 presents head-to-head accuracy bars for AIME2024, AIME2025, and GPQA Diamond, comparing the baseline sample average, self-consistency, and PiCSAR. The blue bars consistently match or exceed the others, which signals better selection with the same 6 samples. The gains are largest for QN8B, so the method pays off when the generator already proposes plausible chains. The consistent uplift matters because it narrows the gap to pass at K without extra sampling. So Figure 2 illustrates how the selection works on a concrete math question. The diagram shows multiple chains from the same prompt, each with a joint score that sums reasoning confidence and answer confidence, which together reflect how plausible the steps are and how certain the final answer is. Majority methods would pick the repeated answer 4, even though it is wrong. PiCSAR instead maximizes the joint score and selects the chain with answer 3, because that chain is both more likely in its steps and more confident in its conclusion. Alright, the previous figure showed a worked example of the scoring. Table 1 reports broad accuracy numbers across models and datasets, which makes the sample efficiency point very clear. PiCSAR and the length normalized variant consistently beat self-consistency and self-certainty, often with only 6 samples, while baselines use 16 or 32. The biggest jumps appear on MATH500 and GPQA Diamond, so the joint score helps especially on harder reasoning sets. This pattern supports the claim that better selection, not more sampling, drives the gains. So Table 2 moves from LLM results to large reasoning models and reports accuracy with 6 samples. The table compares self-consistency against PiCSAR and the length normalized variant across AIME2024, AIME2025, MATH500, SVAMP, GSM8K, and GPQA Diamond. PiCSAR consistently leads, with the biggest gains on AIME and GPQA Diamond, which signals stronger selection under harder tests. The improvements are notable for distilled models, because the joint score filters implausible chains that majority voting misses. Well, the previous table compared large reasoning models with 6 samples. Table 5 expands the view to LLMs and lists mean accuracy with standard errors across SVAMP, GSM8K, MATH500, and GPQA Diamond. The table shows that PiCSAR and the length normalized variant usually top both reasoning confidence and answer confidence, which means the joint score selects better chains. The biggest margins appear on MATH500 and GPQA Diamond, so combining signals helps most on harder reasoning sets. Upper bounds remind us how close 6 sample selection gets to pass at K. Wrapping up, 2 takeaways stand out. Selecting by joint confidence, which adds reasoning confidence and answer confidence, beats majority voting while using far fewer samples, and it generalizes across generators and evaluators, so it is practical to deploy. The broader implication is simple. Smarter selection outpaces more sampling. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.